hope you all are fine and safe. Stay home, stay safe and take prevention for this COVID-19. I am also taking prevention for this COVID-19. And today, the next part of the chapter number 10, that is mensuration, I am going to start with you all. The next part is the synopsis number 3. The synopsis number 3, which is I am going to deal about, or I am going to explain about the right circular cylinder. Right circular cylinder. So, what is the definition of a cylinder? Just go through a figure of a cylinder. Look, I did a figure of a cylinder. See now, A, B, C, D. It is a rectangle. See, it is a rectangle. When you are going to revolve this rectangle in its axis, and this rectangle is going to make a complete rotation, then this type of figure is coming. This type of solid shape is coming, which is called as a cylinder. Especially, a cylinder is dealing with two circles at the base and at the top, and it is having some height involved in it, the height of the cylinder, and there is, as these two base and top are the circles, there is a radius involved. So here the radius is O and B, I wrote here, and O dash C is the radius. OB and O dash C are called as the radius. Then when you extend the radius, you are getting AB and DC are called as the diameter. Then like that, AB, AD and PC and OO dash, AD, OO dash and BC are called as the height of the cylinder. So now it is a combination of a rectangle with two circles at top and bottom. So it is a combination figure of two circles and with two identical circles and with a rectangle, which is giving you a cylinder. Now I am going to say you cylinders are of two types. One is called as your solid cylinder, another is called as your hollow cylinder. Solid cylinder is totally packed inside. It is totally packed inside. No space inside it. So it is called as a solid cylinder. Solid cylinder, whenever it is a curved surface, it is giving you a curved surface. So in case where it is a flat surface, what I said to you, what you are observing, that is called as the lateral surface. Here what you are observing, it is a curved one. So it is called as a curved surface. So it is called as a curved surface. So in case of flat cubed, I said you, it is giving you lateral surface. Now it is giving you curved surface. So we are going to determine the curved surface area of the cylinder, which already you did it in 9th class. Now again I am revising it. The curved surface area of a cylinder is 2 pi r into h. 2 pi r into h. That is square units, because it is an area. So it will come again with a square units. So 2 pi rh. Please try to remember these formulas. Otherwise you cannot touch the sum of these chapters. It is very, very important to go for the formulas nicely. Practice it nicely. Then what I said you, TSA. What is TSA? The total. Total means the top part and the bottom part. Now you are just looking the curve. That means the curve front side and the back side also. That is giving you CSA. Now what you are going to observe? You are going to observe the top part and the bottom part also. So you are going to for a area of total area. That means TSA, that is called as total surface area. What is that? It is 2 pi r into h plus r. I explained you what is h, what is r is the radius, h is the height of the cylinder. It is also coming in square units. It is also coming in square units. Now the space inside the cylinder. How much space inside the cylinder available? That is called as the volume of the cylinder. What is that volume? Volume is pi into r square into h. So these are two direct formulas for you. Please try to remember this. Cubic units. So in solid cylinder you understood. I hope you understood. That means what is a cylinder? When a rectangle is there, when you are just moving the rectangle with a complete rotation, then you are getting a circle at the top and a circle at the bottom, and with the two sides as a height. That solid shape is often called as the cylinder, solid cylinder. Clear? Now the solid cylinder is over for you. I hope you understood it. Now come to the part that is called as the hollow cylinder. Hollow cylinder, you can take some pipe Electrical pipe is a very good example of a hollow cylinder. What is happening in hollow cylinder? You see there is a thickness. There is a thickness of the pipe. So there is an inner circle and there is an outer circle at the top and the bottom also. That figure I did for you. See, this is the inner pipe, this is the inner cylinder, and this is the outer cylinder. This is the outer cylinder. So there are two circles available you at the top and bottom for you. Outer circle and there is an inner circle. So let the outer circle radius be bigger and inner circle radius be smaller. So what is the outer circle area? That is pi into r square. We know it. What is the inner circle area? That is pi into small r square. So each base surface area, what I am saying, see, these formulas are involved in this hollow cylinder. I hope this is the height of the cylinder. Height remains same. Height remains same for the inner and the outer. But what is changing? The changing is the R and R. Either big R is coming and a small r is coming. Big R is for the outer circle and small r is for the inner circle. Small radius for the inner circle and big radius for the outer circle. I hope you understood it. Now you see each base surface area. What is a base? Base is a circle. So what is each area? What is this each area? See, the outer circle area is, what is outer circle area? Outer circle area, OCA. Outer circle area is pi big R square. What is inner circle area? ICA. Inner circle area is pi small r square. When you will go for, you will minus it, then the area of the ring will be calculated. It is just I showed it in dotted lines. So that is the each base surface area. What is that? That is pi into r square minus r square, because you are subtracting this two, taking pi common, r square minus r square square units. So these formulas are very, very important. It is on the board now. If you want to write it in your rough note. Please come with your rough note, pen and the textbook with you. Now you go for the chord surface area. Now chord surface area means this area. This is chord surface area and the back side also up to this much. What is that? That is called as, look at it, 2 pi RH. That means, what is 2 pi big RH? 2 pi big RH means the outer cylinder. See, outer cylinder. The radius is bigger. So outer cylinder surface area plus inner cylinder surface area. Inner cylinder is a small cylinder. That means small radius. Having small radius here. So when you are adding these two, you have 2 pi big RH, 2 pi smaller h. When you add these two, 2 pi is common. Then h is also common. Then what is coming? R plus r square units. I hope you understood. That was square units, because these are all areas. These are all areas. So it will come under square units. Now you see what is the TSA. TSA means the top and the bottom to be calculated with the CSA. Then what is that? You see the TSA is 2 pi RH plus 2 pi RH. That means two surface areas. Two surface areas. Chord surface area of the bigger one. Chord surface area of the inner one. It is outer one. It is inner one. And base area. Each base area. How many base areas are there? Two base areas are there. So 2 into each base area is pi into r square minus r square. So there are two base areas. So 2 into pi into r square minus r square square units. This is called as the TSA of a hollow cylinder. In many books you can able to get the formula for the solid cylinder, but many books may not give you the hollow cylinder formula. Please write it from the board. By thorough listening, you can also able to write it in your notes. Please write it in your notes. Then what is the volume? The space inside. This is the thickness. So the space will be here. That is the space. Inside that, that is called as the volume of the hollow cylinder. What is that? Pi into r square minus r square into h is the direct formula for you. So I hope you understood about the hollow and you understood about the solid cylinders. So this is all about cylinders. Clear? So what is the cylinder? A right circular cylinder. A cylinder, when you are taking a rectangle, and just moving go for a complete rotation of the rectangle, then it will give you a solid shape in the form of a cylinder. The cylinder can be divided into two parts. One is called as a solid cylinder. Solid cylinder, it is fully packed inside, no hollow place inside. So there is a top circle and there is a bottom circle. Two circles, identical circles will be available, and therefore the radius of the circle and the height of the cylinder will give you some formulas, that is CSA, TSA and volume. CSA, the chord surface area. The chord surface area means the surrounding up to this much. When you will go for it, the CSA will come, that is 2 pi RH, and the TSA will come 2 pi R into H plus R. Just wait for 1 minute. I am showing you this cylinder by a figure. Just 1 minute. Now you can see I am just showing a cylinder to you. Clear? It has a top circle, it has a bottom circle, see, and it has a height here, and this is called as the, can be compared as a solid cylinder. So inside it is rigidly packed, and from there is a diameter, there is a pipe, the circle is here, the circle has a diameter here, and half of the diameter is the radius, and this is the height of the cylinder. When I am talking about CSA, I am just moving the cylinder in its axis, and we are going through how much you can see. That is called as the chord surface area. Chord surface area is 2 pi RH square units, and the TSA, when you are talking about TSA, the top circle area and the bottom circle area is going to attach with the CSA. So it is 2 pi R into H plus R square units, and the volume, the space inside it, it is called as the volume of this cylinder, and it is pi R square H. When it will be a hollow one, this part will be empty. There will be inner circle, and a little bit thickness will come for inner circle and the outer circle. The two circles will come like this. I hope you understood the hollow cylinder also. Thank you. Now the next synopsis I am just going for you. That is called synopsis number 4. Synopsis number 4 is the BBI, very important solid shape, that is called as right circular cone. What is that called as? Right circular cone. So everybody familiar with a cone. Today I have a fun with you. I already brought a cone for you. See the cone. It is a joker's cap. I have a birthday cap. What is happening? I will explain you now. See this cone. A cone has one top surface, one top point. With that point, this point is called as the vertex of the cone. Vertex of the cone. And there is a straight line here, which is a little bit slant. This is called as the slant height of the cone. I hope you already understood it in 9th class. Again, I am reminding you. It has one vertex. So it has a slant line, that is called as slant height of the cone. And there is a straight height, which is just inside that. There is a straight height of the cone, and which is creating a right angle triangle. I am just explaining you, see, from the board. What is that? A right circular cone is a solid geometrical shape. It is a solid geometrical shape revolving a right angle triangle. This is a right angle triangle. What I am talking about now in this joker's cap. See now, this is the bottom circle. This is the bottom circle. This is the top vertex. This is the top vertex here. This is the slant height. See the slant height. See the slant height here. And there is a middle height which is joining the vertex and the center of the circle. Circle center and vertex. The line joining, that is called as the actual height. So there are two heights in the cone. Be careful. One is called actual height, another is called slant height. And the bottom is a circle which is carrying radius. If you extend the radius, you will get the diameter. So how the cone, you can generate a cone. When this right angle triangle, see this is a right angle triangle, O, D and B. When you will revolve this right angle triangle, and when it will go and revolving, then definitely this B point will revolve and come to the A point. Then there is a mark on the board, and that mark is this figure. This figure is the when you are, this is written here, a geometrical shape. It is giving you a geometrical shape by revolving a right angle triangle with its axis. With its axis, when you are giving, just revolving the right angle triangle, then this type of shape is coming. So this is called as the cone. You see now, this is the circle. Circle has the center here, and from center to here it is called as the, so look, this thread. I am just explaining with the example of this thread now. See, this thread is the diameter, and half of this is called as the radius, and the center to the points line joining to the top end, that is called as the actual height, and this is called as the slant height. So that much involved in the cone. And it has a CSA, chord surface area. When a person is rotating the cone throughout, then what he will observe? He will observe the surrounding of the cone. That is called as chord surface area or CSA of a cone. Total surface area, this bottom area is a circle, and this CSA whole if you add, then the TSA of a cone will come. So I hope you understood. Now you see, I already wrote here, see, OB, O2B, it is the slant height. That is L. Stop naming stuff there. That is slant height is always called by L. And the actual height is OD. See, OD is called as the actual height, H. Don't be confused between slant height and actual height. Slant height is L, actual height is H. And the BD, look at the BD. BD is called as the radius of the base, that is called as R. So, as it is a right angle triangle, we can apply Pythagorean theorem on this right angle triangle. What is that? Hypotenuse square is equal to base square plus perpendicular square. That one I wrote here. Relation between the RHL. If you want to get the relation between the RHL, then in right angle triangle ODB, then what is the hypotenuse? BO. BO square is equal to OD square plus BD square. I wrote here OD plus what I put H, and with the BD plus what I put R. So H square plus R square. L square is equal to H square plus R square. Okay, it is the parent formula. From there I can draw another two formulas also. This is called as the parent formula. This is the parent formula. Now the two daughters formula can be derived from this. One is called H square. Then R square will be here to minus L square. That will be L square minus R square. Then somebody will find R square. Then what will be it? Then L square minus H square. So these are the two daughter formulas. These are the two daughter formulas involved in this session. I hope you understood this part. Now come to the main part, that is called the formulae part. What is the formulae? Three formulae are there. One is called CSA, chord surface area. I said it, chord surface area. As it is a chord 1, chord surface area total. This one, don't include this. If you include this, this will be a TSA. So CSA means only the surrounding. That is the CSA. CSA is pi RL, direct formula, pi into R into L. L is called as the slant height here. And now TSA is pi R into L plus R, because what is this? Pi R square will be attached. So pi RL plus pi R square. Then pi R is common and remaining is L plus R. So that is that much square units. Then go for the volume. Volume is equal to 1 by 3 pi R square H cubic units. Volume always come in cubic units. I hope you understood it. Look at the thing. In these two formulas, L and R is there. LR. But in the final formula volume, H is there, actual height. So don't be confused, it will be easy for you. In CSA and TSA, you are dealing with L and R. But in final volume formula, you are dealing with the actual height of the cone. I hope you understood it. Thank you. Now, come to the next part of the synopsis. The next part of the synopsis is synopsis number 6. This is also very, very important. This synopsis is also very, very important for all of you. Please try to listen it carefully. That is called sphere. Everybody familiar with sphere. A ball, a football, that is called as our earth is spherical. So everybody has an idea about the sphere. But what is the definition of a sphere? Try to understand what is the definition of a sphere. So the definition is the set of all the points in space. The set of all the points in space which are equidistant from a fixed point. So which points are equidistant? The points in space. So you are imagining some points in the space and which is equidistant from a point. So is called as a sphere. If you join those points, then what the figure will come, what the solid shape will come, that is called as a sphere. So it is called as a sphere. The fixed point, which point is fixed for you and from where the distance is going to be measured, that point is called as the center of the sphere. I hope you understood. So the fixed point is called as its center. So what is the definition? Definition is the set of all the points in space. The points are in space you are joining those points to a fixed point and getting your sphere, getting your solid set, that is called a sphere. So some figures I did for you, see. Before that, I want to say you a sphere and a circle has a little bit difference. What is that? A sphere is having a little bit thickness in it. Thickness. You see a ball, when you will just turn the ball out, then you will see the ball having some thickness, but the circle has no thickness. But the same thing, the points which is in the space equidistance from a fixed point, if you are joining, you are getting a circle also. But a sphere having a little bit of thickness in it. So I am showing it by my figure. See, the first figure I showed you, there are a lot of points in the space A, B, C, D, E, F, G, H, I, J, K. These points are in space. What I did, I joined to the point which is in center. What is the point? The point is O. O point is joined to A, B, C, D, E, F, G, H, I, J, K, L. So these points are joined to the center and giving you the distance OA, OB, OC, OD, OE, OF, OG, OH, OI, OJ, OK. So look at this. The distance between all the points is remaining same throughout. The distance between all the points is remaining same throughout. Why? Because if it is remaining same throughout, the distance between the fixed point and the point in the space, if the distance are going to remain same throughout, then when you are joining the line, you are cutting the shape of a sphere. That is called as a sphere. And another line I showed you inside, see, it is for your thickness. The sphere has some thickness in it. So definitely there is a outer sphere and there is an inner sphere also. Okay. So now it is this. What is this? See, O is called as the center now. My center, that is my fixed point. That is my fixed point. And OA, OB, OC, OD, OE, OF, OG, OH, OI, OJ, OK, all are joined to the fixed point. That is center. And all are same and called as the radius. So now another figure I did it for you. See now. Here you see. Here is the outer sphere, here is the inner sphere, so there is a thickness in between the two spheres, there is some space inside it. But that is the difference of the sphere to a circle. Circle has no inside layer in it, so but the sphere has some inside layer in it. That is called as the thickness. So now you see the line joining the center and the opposite to the opposite surrounding, opposite periphery is called as the AB. AB is called as the diameter. I showed it in diameter. Half of the diameter, that is OB. OB is called as the radius. So here it is written. The most important figure, another one I want to show you, that this is the spherical cell. Try to understand what is a spherical cell. So no teacher will say you, no book will say you. In IIT book it will be there. What is a spherical cell? You observe here there is an outer sphere. Yes, there is an inner sphere. So what is this? This area is called as spherical cell. This is called as the thickness. That is the thickness of the sphere. And that thickness is the area. When you are going to calculate the area, then what is the outer area? This is pi r square. And what is the inner area? That is the pi small r square. So when you are subtracting pi r square from pi r square small, then you are getting the area of the spherical cell. It is not in the formula, but try to understand what should be the thickness. The thickness is the big R minus the small r. From here to here it is small r. From here to here it is big R. So when you are just subtracting big R from small r, you are getting this R minus R. So this is the thickness. This is the thickness of the sphere. Understood now? So at the points which are in the space, which is equidistant, they are all equidistant to a fixed point. The fixed point is called as the center and they are joined. They are all equidistant to the center and is giving you a form of a sphere. The solid figure, that is called as a sphere. The fixed point is called as the center. The fixed point here, it is the center, and the obtained figure is called as a sphere. I hope you understood it. Now some formulas are involved in it. What are the involved formulas? The CSA, the TSA and the volume. CSA, I said you, the chord surface area and PSA. If this thing is like this, then there is no difference between a chord surface and a total surface. Both are same. So the chord surface and the TSA in case of a sphere are both are same. I wrote it here and the formula is 4 pi r square. Try to understand 4 pi r square square units. So this formula having the CSA and TSA both are same. And when you come for the volume is direct formula 4 by 3 into pi into r cube. When the radius is said to be r, because we are putting r as radius, so 4 by 3 pi r cube. I hope you understood this synopsis 6 called as the sphere. Now I will say the hemisphere. Just try it. Now come to the next part of the synopsis after the sphere. That is the synopsis number 7. The synopsis number 7 is on hemisphere. Hemisphere. That means half of the sphere. Hemisphere. So let's go for the definition of hemisphere. A plane through the center of the sphere. A plane through the center of the sphere divides the sphere into two parts. A plane through the center of the sphere. This is the plane. Try to understand. This is the plane which is dividing the center into two parts. Each part of it is called as a hemisphere. So this is one part, this is next part. So first part, this is a hemisphere and this is another hemisphere. So this is the plane. When this plane is coming to the center and divides it through its diameter C and making it into two parts, then each part is called as a hemisphere. That is half of the sphere. If the hemisphere figure has been done for you, this is the part. So now see, this is the diameter and this is the radius. Okay, so radius r. So involved formula in this, nothing to go for it. It is the half of a hemisphere, a plane which is dividing the sphere into two equal parts, and each part is called as a hemisphere. So hemisphere, the involved formula for this is the curved surface area, total surface area and volume. Here in the sphere case, there are the CSA and TSA are 1. It is only 1. But in case of a hemisphere, that one you have to remember, that is the confusion part. In the case of a hemisphere, definitely the CSA and TSA are different. That means there is a chord surface area, because this part and top part is giving you the TSA. But only what you are going to see, the surrounding, that is called as the CSA. Therefore, the CSA is 2 pi r square and the TSA is 3 pi r square units, as it is area, and the volume is equal to 2 by 3 pi r cubic units. This is cubic units. Cubic units. Understood? So I hope you understood this synopsis. Here the idea about the surface area and volume. Surface area and volume. In my first video, I draw 4 parts for you. For exercise 10.1, for exercise 10.2, 10.3, 10.4. So like that, the first exercise part is over now. That is surface area and volume. In your book also there is a big table for the formulas regarding all the solid shapes. Please go through it nicely, because formulas are very important. If you don't know, you cannot touch the sums. So regarding this, you can solve some easy examples first. After that, go for the exercise 10.1. Many students are waiting for homework. Don't wait. Please start to do the sums, by which you can easily complete the things in time. Thank you very much.